In this video, we're going to walk through one of the most practical AI automated workflows built with n8n, and specifically in the use case of document classification. So the best way to think of it is it's ultimately two steps. So one is to download and extract the contents of a document. Two will then be summarizing. And then from there, we're going to be using AI to conduct some level of reasoning to classify, provide a score, and a specific output that we want. And then we're going to upload that all back into a database like a Google Sheet. Just to give you a quick overview of how the flow works, we're just going to run it from scratch. And so the initial trigger is going to be a document being added to a OneDrive that I've set up. From there, we're going to download the file, extract the details from that PDF file, pass it through two simple LLM chains that are going to be powered by two different Google Gemini models. We're then going to parse out the output from this final node and structure it in a way that we can upload it back into Google Sheets, and then we're going to upload everything back into Google Sheets. This is the final output. And then if we look at the document itself, it's about 37 pages. It's very dense. A lot of it is text. There's images. It's not perfectly structured. And this is, in my opinion, what I believe to be one of the killer use cases for n8n and automated workflows, because for a lot of organizations, the ability to go and sift through documents, read through them, get a detailed summary, and then classify them can take a lot of manual effort. I think these are all some great examples of different use cases. So that's how I've designed this flow today. And just again, walk through the different steps just so you can see how it looks under the hood. The trigger is ultimately going to be downloading. So we would take all the documents from that drive that would be known as the data room, throw everything into OneDrive, which will then kick off this flow for each of those documents. We then download the contents of the file. And what you'll see here is this is all just the metadata for the file itself. And ultimately, once it gets downloaded, we actually have to convert this because it's in a PDF format into a output that can then be used for the remainder of the flow. So that's going to be this extract from file node. When you look at it, it's pretty straightforward. It doesn't look like it's this incredibly dense output, but when you actually open up the text, that's where you're going to see that this is the entire breadth of content from within the file itself. And this is going to be, hundreds of thousands, or maybe tens of thousands, maybe a better accurate estimate of the contents of the file in terms of tokens that are going to be passed through. So now this is where I really want to spend more of the focus. And I think this is very important when you think of designing systems like this for a scalability perspective and also from a cost perspective. So the first step that we're going to do is actually text summarization. And the model that we're going to be using here is actually the Gemini 2.5 Flash-Lite model. And why I think this is a more appropriate model than something more powerful like a 2.5 Flash or a Pro model is that the latency is very low, and this thing just eats tokens at a fraction of the cost compared to even the 2.5 Flash model, which is a really powerful workhorse, but is actually still more expensive. And so what I would recommend when you're thinking of these workflows is think of the underlying engine being the LLM model that you're using and think of the use case for it. And a good analogy I like to think of this as like car engines. So you wouldn't want to take a Mack truck, 18-wheeler to go on a grocery haul, right? So you really want to think of what is the use case and what is the most appropriate model for that use case. And so what I really like about Google AI Studio is you can sift through all the different models. You can actually compare them side by side and test different outputs to see the costs associated with it. But they do give a pretty brief overview on the right-hand side here when you hit model selection, just to compare them. So I'm on the Gemini filter. And when I look at the 2.5 Flash cost versus the Flash-Lite, it's significantly cheaper, right? So we look at the Flash-Lite model, its input is at, the Flash model, is at 30 cents per input. So 3 times more expensive compared to the Flash-Lite model. And in terms of the output, it's almost 5 times more expensive, actually more than 5 times more expensive than the Flash-Lite model. And so in this context here, what it's really doing is we're taking all of this text. So I'm setting it up as a defined below source for the LLM chain. And then what it's doing is I just take the text input, I can grab this dynamically, throw it over here. I'm not going to do it twice, and that's all the text input. And then I just set a very simple system prompt where I'm just saying you must carefully review a comprehensive input of text and output an executive summary paragraph about the context. And it just crushes that. It does it perfectly every single time. And this is a very high-level overview of what the document is about. And why it's so important to do this step first is because then when we pass on this information to the document classification model, we actually don't want this LLM chain to be having to use the entire breadth of tokens for the full document. We actually want it to be doing its classification based off the summary. So when we go over to the document classification, this is now actually where we're going to use a more expensive model. We're actually going to use the 2.5 Flash model. And the reason for that is because this process actually would involve more reasoning. And that's where this model will excel compared to the Flash-Lite model, which is going to struggle with respect to reasoning. But I just had this up just as an example. So I think the LLM chain, something I wanted to touch on as well, like this node, I think is the most powerful nodes, or one of the most powerful nodes in n8n, because it's very strict. And what you're trying to do is you can write, here's the input, here's your prompt, do this action. And it's very, very clean. It's a very predictable outcome. And the reason for that is because n8n is actually built using the LangChain open source framework. And so I think a good analogy to think of this is like all these nodes are like Lego pieces that you're using to put together to create an agent or a workflow. And I think one of the most killer use cases is this simple LLM chain. So if you were just to go to LLM chain, this is the node that I use so frequently. And so this chain now, it's going to be taking in, again, here's the text summary. I'm grabbing this from the prior node, and then I have the system prompt. And this is ultimately where, I would say the IP of this system really is probably the most valuable step, because this is where you're going to make it optimized for the business that you're actually working with, or the use case that you're working with. So you can go to Grok, Claude, Gemini, pick your favorite model, and describe what we're trying to do here. So ultimately, it's a 3-step output format. So I want classification. So is this document relevant? Is it irrelevant? Or is it review? So is this something that a human should actually review? I want it to apply a confidence score of 0 to 100 about how certain it is for that classification. And then I also want it to provide its reasoning. So provide a text output in 2 to 4 sentences that describes why it gave that classification and confidence score. And I think these are all incredibly important with respect to auditing and doing evaluations for the quality of this workflow over time. So again, use this as a starting point just to get started. And then over time, as you start putting more documents in, you'll want to refine this prompt to get it as high quality as you can. And maybe even, if need be, tweak it to use a more a higher level reasoning model if needed. I also like to put under the guidelines here to err on the side of review if information is ambiguous or requires context, because you want to actually create more edge cases, because that's going to be a great learning opportunity to then go back to this prompt and iterate and make it better with examples. So then we're taking that final output, and if you actually see the output, it comes out as one giant text blob, and that's going to be a struggle to then actually upload that into Google Sheets. So then what we're going to do is take a code in JavaScript node. And again, I don't have a coding background. All I did was take this JSON input, go to your favorite model and say, hey, can you actually write me a JavaScript code to then break this up into 3 separate outputs? So I have the classification, confidence score, and reasoning, and then everything gets uploaded back into Google Sheets. And so you're just mapping this to each of the columns. So here's the final output. We have the name of the document, the document type. We have the uploaded date, the status, page count, classification, confidence score, so 1 being 100. We have the reasoning, and it's, again, this is all great for auditing, so you can actually read through and understand how the model thought about this particular document in the context of us doing risk assessment for an insurance brokerage. And then we have the document summary. And again, this is just a fantastic workflow that you can use in so many different use cases for so many different businesses. It saves so much manpower. And this is what large language models thrive at, is taking unstructured data, processing it, summarizing it, and classifying it in a repeatable workflow.